Hello friends. Today we are going to talk about set theory or sets. So in mathematics the concept of sets is very central. It has a very important role and it is used in almost all the branches of mathematics. So what we are going to understand today in this video is what it is actually. So as mathematicians, as students of mathematics, we need to understand the world in a more objective manner. When we say objective, I mean we consider everything as a single entity. For example, this blackboard, it's an object. In the same way, everything in this world can be considered as an object. So if everything is an object and we deal with groups of such objects, then those group of objects become collections. Now, for a collection to become a set, it has to satisfy certain properties. So we say that a set is a collection is a set only if it is well defined. So basically, a set is a well defined collection of objects. That's it. So how can you say that a given collection is well defined? So just for example, assume that I have a collection of few objects. Maybe it's a collection of my favorite music. Whatever music I like, I'm making it as a collection. Now, is this collection a set? So just think about it. I specifically said this is my favorite music. So when I use such subjective terms like my favorite or my friend's favorite, it is very subjective. So if he likes a certain kind of music, it may not be liked by others, or if he doesn't like some music, it may be liked by others. So everybody's collection of music will be different, so it cannot be considered as a set because they are all different. But if I say a collection of even numbers, so there is no ambiguity, there is no misunderstanding what will be there in the collection. We know that the collection will contain the numbers 0, 2, 4, 6 and so on, all the even numbers. So this collection is now a set because it is very well defined. If we get any other object, whatever it may be, we can with 100% conviction, with assertiveness, say whether that object will belong in the set or it will not. For example, if you have the number 3, obviously it's an odd number, so it will not belong to this particular set. In the same way, if I get an object which is not a number at all, say a chair, obviously it is not a number, so it cannot belong to this particular set. So in that way, we can understand what sets are. So if you have this understanding of set, we can proceed further and we can start learning how we denote certain sets. So in mathematics, generally the sets are denoted by capital letters. So the capital letter A, B, C, you can use any of these letters to denote a well-defined collection or a set. And the individual members that are inside the set are denoted as small letters. So the small letter A doesn't necessarily mean that it is there inside the set. It is just denoting one of the members of the set. For example, if I have the set of natural numbers, so the set will consist of 1, 2, 3 and so on. So all these numbers are there in this particular set. If I want to just represent one of these elements in general, I can just denote it by the letter N or E or whatever you like, the small letter. So in this way we can say whether this particular element belongs or it doesn't belong to a particular set. So when we say a particular element belongs to the set, we use the symbol epsilon. And when we say it doesn't belong to the set, then we use the epsilon with a strike. So in this way, these are just certain basic notations which are followed generally when we talk about the set theory. It is accepted globally and it is accepted across all the fields of mathematics. So notations are very important. So it's always better to start using them appropriately so that when you read certain subjects on mathematics, you can easily understand what the person is trying to say. That's why there is a universally accepted notation. In the same way, there are certain letters or certain notations which are reserved. For example, the set of natural numbers, the notation is script n. The set of integers, script z. And similarly, whole number has a reserved notation, the rational number has a reserved notation, and irrational numbers, real numbers, certain sets which are widely used or which are used repeatedly, they have a reserved notation. So if you understand all these things, we can proceed further and we can discuss about the different properties of a set, the types of a set. So we will talk about this in the later video. Thank you.